Welcome everyone. Today I am continuing with the trim questions from past papers. So today the topic for the trim question is achieving desired trim. So there are 3-4 types of trim questions are there: keeping one and draft constant, achieving desired trim, finishing on even keel. So one of them is to achieve desired trim. This is from the past papers on MV Hinship. MV Hinship in condition number 8 has to discharge 300 tons prior to sailing. Calculate the position with respect to aft perpendicular from where this weight to be discharged to enable her to sail trimmed 1.5 meters by the stern. Also find sailing drafts forward and aft. So here a condition, initial condition of the Hinship has been given, which is condition number 8. So we have to refer to condition number 8, and from there in that we have to discharge 300 tons of cargo. We need to find the LCG of the cargo, like how many meters forward of aft perpendicular, from where this 300 tons should be discharged in order to have 1.5 meter trim by the stern on the sailing condition. Final sailing condition, find 1.5 meters. Okay, so as they have given us condition number 8, so I need to know what is my present displacement as per condition number 8. Displacement given in condition number 8. So if you see, this is the condition number 8. Condition number 8 is this, and you see all the columns, weight, kg, vertical moments. You come to this one. This is a LCG, forward of aft perpendicular, and the last column is longitudinal moments. Okay, so from here I can get what is my initial displacement. Okay, you can see here displacement given 16133, displacement 16133 tons. So from condition number 8 I get displacement 16133 tons. I have to discharge 300 tons of cargo, so I will subtract minus 300 ton and I get my final displacement for sailing. This is a sailing displacement 15833, 16133 minus 300. Now I have my sailing displacement, final displacement for sailing. I can enter hydrostatic particulars and extract the various parameters. Refer hydrostatic tables for displacement 15833. So for convenience, I have here the extract of the displacement and draft from the hydrostatic tables for the range of displacement. So it's 15693, 16161 range. So 15833 falls somewhere in between these two displacement. So I will now interpolate for my draft between 7.6 and 7.8. You can see for this displacement 15833, and I'll get my hydrostatic draft. I'll interpolate for MCTC, LCB, and LCF. So condition number 8, all the conditions of Hinship are for salt water. Ship is floating in salt water, so no density correction will be required anywhere. So we will just take the values from the hydrostatic tables on condition page number 8 of hydrostatic particulars. Okay, so hydrostatic draft interpolating for 15833 tons displacement, I get hydrostatic draft 7.660 meters. It's between 7.6 and 7.8 range here. So I get 7.66 meter hydrostatic draft. MCTC 192.638 ton meter, which I interpolated from here. Okay, and LCB 72.675 from here interpolation for the displacement, and LCF 70.919 interpolation from here for my displacement of 15833. I know the formula for total trim is LCB minus LCG into displacement upon MCTC into 100. So since this is the formula for final trim, so final trim means all parameters must be for final condition. LCB, LCG, displacement, MCTC, all must be for final departure condition because I am using here final trim. My desired final trim is 1.5 meters by stern. As per the question, the question says that vessel should be trimmed 1.5 meter by stern at the time of sailing. So this is a sailing trim. Total trim desired 1.5 meter by stern. So I can insert this total trim here in 1.5 meter. LCB I have 72.675. MCTC I have, displacement I have 15833 final displacement. So I can get the final LCG for the final condition from this formula. Okay, so I put in place of total trim 1.5, LCB minus LCG into this final displacement 15833, final MCTC 192.638 into 100. So I insert the values of LCB here. LCB minus LCG comes out to be 1.825. Put the value of LCB 72.675 from here, and 72.675 minus 1.825, I get 70.850 meter. This is the final LCG after discharging cargo. So this must be my final LCG in order to produce desired trim of 1.5 meter by stern. Vessel's final LCG should be 70.850 because here I have used all final condition parameters, particulars of all final conditions, final trim, final LCB, final displacement, and final MCTC for final condition. So I got final LCG 70.850 meter. Now you make tables for weight, LCG, and longitudinal moments. You must always first start with the initial displacement before the cargo is discharged. Whenever there is any final LCG or a kg you are finding, first must be the initial condition before cargo operations. So before I discharge 300 ton, what was my initial displacement, initial LCG, and initial longitudinal moments? Since we have been given the condition, which is condition number 8, all these three figures are straight away available from the condition. So if I go back to my condition here, and you see here the last two columns, one is the LCG and one is the longitudinal moments. So LCG for the initial condition is 70.045. Longitudinal moment given is here is 113.0041. Okay, and you know initial displacement is 16133. So I insert that here. Initial displacement 16133, LCG 70.045, longitudinal moment 113.0041, straight from condition number 8 as given in condition number 8. So if you multiply this 16133 by 170.045, you may get small difference. You may not get exactly 113.0041, but since we have been given condition number 8 in the question, we must use the value given in condition number 8, which is 113.0041. Okay, now cargo to be discharged is 300 tons. Assume X meter is the LCG of the cargo So what will be the longitudinal moment produced by the cargo? 300 multiplied by x, 300x. And since we are discharging cargo, displacement will be reduced. So we subtract 300. So 15833 is the final displacement. And longitudinal moments also we will subtract because cargo is being discharged. So 1130,041 minus 300x. Formula for final LCG is final longitudinal moments upon final displacement. Final LCG we have found here 70.850 from the trim formula. I can insert that here 70.850. Final longitudinal moments is from here 1130,041 minus 300x upon final displacement, which is 15833. I get the value of x 27.577 meter. This is the LCG of the cargo. Means cargo should be discharged 27.577 meters forward of the aft perpendicular. This is the location from where 300 tons should be discharged. In other words, this is the LCG of the cargo. That is the first question they asked, from where the cargo should be discharged. This is 27.577. And what will be the final sailing drafts? For final sailing drafts, I need my change in the draft forward and aft due to trim, which is called trim aft, trim forward. Okay. So due to trim, what will be the change in my draft aft? That is total trim into LCF upon LBP. 1.5 meter the total trim, LCF 70.919, which we have found in the first step only for the final condition. Our final displacement was 15833 tons. For that, we have found the LCF 70.919. 70.919 upon ship's length between perpendicular 143.16, it gives 0.743 meter is the change in the draft aft due to trim or trim aft or for aft trim, whatever you call it. Then forward trim or change in the draft forward due to trim will be total trim, which is 1.5 meter minus trim aft 0.743 gives 0.757 meter. This is the change in the draft forward due to trim. So these two changes in the draft forward and aft because of trim, TA and TF, they are applied to the hydrostatic draft. Final hydrostatic draft for displacement 15833 was 7.66. This is the final hydrostatic draft. If the ship was even keel, draft forward and aft will be 7.66 also. But ship is trimmed by the stern, so the forward draft will be less, aft draft will be more by how much? TF and TA, which we have found here. This is TA and this is TF. So since ship is trimmed by the stern, so TF will you subtract because forward draft will be lesser than the draft at center of flotation. So 7.66 minus TF 0.757 and aft draft will be more because we have trim by the stern. So add the TA to the hydrostatic draft 7.66 plus 0.743 and you have it here 0.743 and you get final sailing draft forward 6.903 meter and aft 8.403 meter. Okay, this is forward, this is aft. Well, thank you very much. That's all for this question. Any comments you can leave in the comment, any doubts, so I can always clear them. This is a very straightforward question. I hope I am able to explain the working. Thank you very much. I will be putting one more, all the one question on all kinds of trim questions which have appeared in the past papers.